Oops. All right, we're going to get started. Can you get a quiet, please? Okay, first of all, very important, couple very important things. Number one, sound carries in this room, okay? I can't always hear it because I have bad hearing. I can hear it right now. So if you have a problem with someone talking around you, let me know after class what section and I'll address it in the next class, okay? If I don't hear it, okay? Number two, the attendance is going around. Please pass it this time. I gave everybody a free pass last time. I'm not going to do it today. Make sure it gets around. So TAs, if you wouldn't mind helping, making sure it gets around to everybody, okay? Middle section, I don't think got it last time at all. All right, so today we're going to finish up the intro to MIS stuff from last time. We have the live streaming on. It will record. I fixed it so it'll actually show the slides as well, okay? What it will not show is when I pull up the document camera, that stuff won't be recorded. I have no way to record that, okay? Not humanly possible in this room, but everything else will be on there. The first lecture is a separate link. I put it in the syllabus. I wasn't able to include it because I don't want it to be publicly listed on the internet for that one, okay? Because I had video on it. So this one, no video. It'll have the slides. I have the audio as well, okay? And it is recording now. All right, so if you have not done the formation of a group last time, after class, exit and do it out there so that the next class can start, okay? You have until tomorrow at the end of your discussion to get into a group, okay? Then you need to have your minutes prepared. So you need to meet between now and Tuesday morning, which means really probably Monday, and prepare your first meeting minutes. On Tuesday of next week, there will be a stack that you can put them in over here, okay? You'll turn them in. The TAs and I will go through, assign you group numbers, assign each individual letter for your presentations later on, and then you will get a group set up in iLearn. You'll be able to submit things, be able to see each other's email addresses if you haven't already exchanged that, all from iLearn, okay? So that's very important. So today we're going to start with information systems, and then we're going to finish up with computers, okay? And that's why I've got a computer sitting here. I hope that we can, especially since I lugged it around the campus today, hopefully we'll be able to have time to actually tear it apart and show you the components, what they look like, so you can understand what's inside each of your computers. Okay, so let's begin. Okay, so last time we talked about accessing information, and the most common way that we use today would be graphical user interfaces, okay? So things like Windows, Mac OS, okay? Web pages. That's how we access information today. The reason we do this is because it's comfortable, it's easy to use, okay? Somewhat flexible. How's the audio in the back, by the way? Good? Okay. All right. So one example of a tool we use to view data is called Tableau. And some of you had already asked me about this before class. Okay. Tableau is a web-based system with software you can download to your computer that allows you to analyze data and view that data. If you do the Tableau lab, by the way, let me stop about the labs and mention one thing to avoid any further questions about it. We will cover the material in the labs at some point during the quarter, okay? So if you're not sure how to do a lab, I will at least talk about the material, and you're welcome to come to the office hours, which I've set up the group office hours for Friday, starting tomorrow, every other Friday in the undergraduate suite, and I can fit 10 people at a time. You can sign up. There's a link in the on the course website, and it's also in Slack now. Okay? You can sign up 10 people at a time per slot, and we can go through any questions you have about labs, projects, whatever, okay? Now, the other method we use is command line interfaces, and one of the labs will talk to you about how you do command line interfaces. These are used mostly by MIS professionals and software developers, okay? Most of you will probably never use unless you do that lab, which is a very easy lab, by the way. It's a game. Okay, so the command line lab is actually a game that you can play from MIT. It's pretty cool. Okay, at least I think so. They can be very difficult to use though, because you've got to remember how to do something. And I think for me, this is easier because when I started using computers in elementary school, we had to do everything on the command line. So we had to learn the commands. And then Windows came out and kind of ruined it for everybody because now you don't learn this anymore. We will talk about it. I will give you a demonstration when we get a little bit further in the course. You'll see what I mean. It's very powerful, but it's hard to use. Okay. Hopefully we can flip that by you playing that game. You get a little exposure, and maybe if you're interested, you'll do some on your own. Okay. The third one that I mentioned on Tuesday, but we'll refresh here, is application programming interfaces. This is what developers use to make things functional. Okay. This is how we're able to have data from Google show up in Slack if we want. This is how we can do open a Zoom call from Slack. This is how Professor Bot can respond to you in your questions. Okay. APIs make that all possible. Without APIs, we'd be in a world of hurt. Okay. We'd be doing a lot of things manually. So information is produced in a number of ways, okay? We have raw data, files like Excel. A CSV is just, stands for comma separated values. It's just a text file where the fields are separated by commas. There's also a TSV, less common, tab separated values, okay? When you're in Excel, by default, it saves as an Excel file. But let's just say you want to be able to import that data into a different system. Generally speaking, you will do an export to a CSV file or a TSV file, depending on what you need, and that makes it in a machine readable format for other computer systems. So when I, for example, go and do your grades, I can export your grades to an Excel file or a CSV file or a TSV file, and then the TAs and I can go into Excel and actually enter them. It's a little bit easier than doing it in iLearn, okay? JSON is another type of data interchange format, okay? JSON stands for JavaScript Open Notation, okay? It's a standardized way for businesses to exchange data. This is, by the way, the most common way businesses exchange data now with each other is JSON file, okay? XML is another file that businesses use, tends to be less common today because JSON is much more featureful, okay, and easier for you to use. An XML file is a lot like looking at the code for a web page, okay? It's kind of confusing and hard to look at. A JSON file, if you looked at it, you would know exactly what that file meant, okay? It's very human readable, but yet it's still readable by the machine. Now, we also have graphics. We have things like graphs and dashboards. And so in my career, I've used a lot of dashboards for data, okay? I worked for a big company, Oracle. We own, when I worked there, they had databases. They're like one of the bigger database providers, okay? A lot of data, I'm not going into the server and looking at the database directly. It's displayed for me in a management dashboard. The critical things I need to know. How much is my team costing me every hour that they're working, okay? How much overtime am I paying my team? Have I exceeded my budget that my organization had? What does it look like from a customer satisfaction perspective for the customers I'm responsible for? That's the type of data that a dashboard will display to me. Now I can go out and I can create a graph manually in Excel. How many of you have done that? Okay. It's kind of a hassle, right? When we get to the Tableau, if you choose to do the lab, I, by the way, strongly recommend it, and we'll have someone on campus here, a student who is an employee of Tableau, come in and talk about their product and how it's useful for you. It's used in the upper division classes a lot in the business school, okay? That allows you to generate those graphs without all the work you do in Excel and have them live update based on the data changing. You don't have to go redo it each time. And so to give you an example, I created a database for a client. One of the things that my consulting firm does is we do compliance consulting. And so I had a client who wanted to be compliant with a particular law. So I created a database, and then I created a dashboard in Tableau that automatically generated new graphs and stuff for me and for my customer on the fly as needed. Every time that I logged in and refreshed the page, there was new data. I didn't do anything else with it. It just got whatever was in the database, okay? That's the power of these tools. Mixed reports, we can basically have a predefined report. Let's say our quarterly financials. That's a predefined report. We define it in an information system. We can also, as people in business, go out and create ad hoc reports. Let's just say I'm working on a project and I determine I need some data and it's not in the system and in a predefined report. I can go and say, create a custom report, and I can go and say, I want it from this data source, this data source, this data source, but I only want to see the information about the accounting department and the financials of this particular company that we're acquiring. I don't care about all the other data. I have the ability to generate a customized report, okay? So that gets me on to information technologies. And if I'm going a little fast, I'm sorry. You can play back the YouTube video at like half speed if you want to, okay? If you want to review it. First thing is computer networks. We'll talk about that in detail in a few weeks, but this is things like local area networks. We're all on a LAN in this building, okay? This campus has its own LAN managed by the IT team. The LAN connects to what's called a wide area network. And on this campus, there are many wide area networks we connect to. One is obviously the internet. That's a form of a WAN. There are also academic WANs for just colleges and universities. And this campus happens to be one of those that about a decade ago invested heavily in what's called dark fiber. This connects UCLA, UC San Diego here, and a bunch of other institutions across the country with really fast network to do research together, okay? So those are the types of things that we have for computer networks. Then we have things like database systems. So MySQL, MongoDB, Oracle, Microsoft SQL, these are all types of databases. Then we have computers. So we all have laptops or tablets or smartphones or maybe a desktop, okay? Desktop being this honking thing here, which I will pull out later, okay? I carry this across campus for all of you, okay? Internet of Things, okay? Oh, actually I missed one, servers. Servers, I thought about it, but there was no way I was gonna go steal a rack of servers from the server room and roll them over here, okay? Think of a refrigerator, okay? That's how big a rack of servers typically is. It's a big cabinet with a bunch of computers in it to run websites and business databases and things like that, okay? So a server sits in this big rack, and there can be different types of servers. There can be things like storage, and there can be things like network equipment. They fit in these refrigerator racks. If you go out, and some of you are on the internet anyways, if you went out and Google computer server, you'd probably, one of the first things you'd probably see is Google's data center with all these blue, red, and yellow and green refrigerator looking devices. And inside them, there's a bunch of servers, okay? Servers are usually in a room, used to be a room this size. Yes. On the slides, yes. The first one did not, but this one is now getting the slides. It's being live streamed. There's a little delay on the live stream though, so I wouldn't recommend doing it in here because it's like 5-10 seconds delayed from me speaking before you'll see it on the internet. But if you're not able to make it to class in time, you can live stream it on your way over here and you can see it, and it just be a little bit delayed, yeah. And then the recording will be available. That actually is a good question. The recording will be available as soon as class is done. The recording's available. Okay, as soon as I turn off the live stream, the recording's available. If you want subtitles though, those take time to generate, and I have to manually go in and specify the type of subtitles. So I usually get to it after class. Then Google has to go out and analyze the whole video and do the subtitles. That usually takes a couple hours. So if you need the subtitles, you're probably going to need to wait until tonight to see the subtitles, okay? But there are automatic closed captioning on there if you want that, okay? But on the server part, used to be rooms like this existed. They weren't slanted like this, but the floor was raised above the real floor. Okay, it's called a raised floor. That's where servers live. It's a room with heavy air conditioning. It's a clean room, so you and I wouldn't be able to just walk in there and go check it out. Here on the campus, there used to be a facility in what's now the School of Medicine building. I don't know if it's still there or not, but that room was where the server room was when I worked here as a staff member about 12, 13 years ago. Okay. Most organizations have even larger data centers now that they use facilities provided by Amazon, Microsoft, and Google. Those are the three main cloud providers. That's where we mostly see servers today. Companies like Google and Amazon, though, run their own data centers. PayPal runs their own. eBay runs their own. These are facilities, imagine at least 10 to 20 of these rooms in size, okay? Full of computers. That's what a data center looks like, okay? And if you're ever lucky enough to go do a tour of one, which would be maybe if you were going for an interview or something, you might get to do a tour. It's really cool to see, okay? Wear ear protection though. That's why I have hearing problems. All right, Internet of Things. Some cars now are connected to the internet, okay? I have a Chevy and it's connected to the internet, okay? It can update the information about the economy of the vehicle. I can remotely start it and start the air conditioner. I can unlock the doors, that sort of thing. Okay, it's connected to the internet. Smart homes are also IoT devices, okay? Smart homes like doorknobs that automatically unlock from your phone, or a camera, or a doorbell, that sort of thing. That's an Internet of Things device. Businesses use this as well. Okay, so I've worked in environments where I had an office that had an IoT thermostat. It was a smart thermostat. But let me tell you how I fooled the thing. It detected how many people walked into the room, and it would adjust the cooling accordingly. Well, I get hot, okay? You guys are probably cold. I'm hot right now, okay? I would walk in, it would be roasting in my office. So I would get down on the floor, and I'd crawl back out, and I'd walk past it again. And I do that about 8 or 10 times until it got cool enough for me. And finally, facilities told me I couldn't do that anymore because the fire code said I couldn't have 10 people in my office. It was too small. So these Internet of Things devices are everywhere, and businesses use them because they're helpful. Sensors. Imagine you've got a remote facility with sensors to tell you what's going on. Say you run a food production facility. Without a sensor and an IoT device, you'd have to have someone constantly checking that every aspect of that facility to check the temperature. Okay. Anybody work fast food here that wants admitted? I used to. Okay. I'll raise my hand. Okay. You have, as a manager, you have to go around and you have to check temperatures on things. IoT is solving that problem now. You no longer have to do that. It checks the temperature. It automatically updates a dashboard. The manager's not running around with the checklist anymore. Frees up the manager to actually service the customers. Okay. Websites and e-commerce. This is another aspect of information technology. Pretty much everything we do today has some sort of website behind it. We all use e-commerce all the time. This is a new thing for the last, say, 20, what is it now, 2020? So about 25 years we've had websites now, okay, in e-commerce, right? So information systems, they help us as an organization become more competitive. They allow us to get all of our finances, our HR, our supply chain, our operations, marketing, sales, manufacturing, get all that information together, share it to make better business decisions, okay? Now, examples, is anybody a supply chain manager concentration in here? Okay, marketing, HR, finance, IT, okay? These are all systems that we use. If you do the Enterprise Systems Lab, Odoo is going to allow you to do many of these things. Not all of them, but many of them, okay? And you're gonna learn that functionality. Odoo is an easy way to learn an ERP. When you get into business, you're gonna have to learn a much more complex version. Usually they're SAP, Oracle, Workday, things like that. A little bit more complex. Odoo is very easy for you to use though. And that's why I picked it for the class. It's very easy. Anybody should be able to pick it up by just playing around with it, okay? But these information systems allow us to exchange data and make better business decisions. In the future, we have things like they're very important skills and whatnot. Analytical reasoning, critical thinking, and experimentation skills, I think, are the most important skills that you can walk away from in college, okay? These are the things that you'll learn in this class. When you're doing those labs, they're not busy work. I could have easily just assigned you problems from the textbook, okay? Or labs from the textbook provider. But what I found is they're not useful. They don't really help you with your career. They help you get a grade, but this class is not just about getting a grade. Okay. I hope everybody in this class gets an A, by the way. Okay. My goal is not to fail anybody, but you have to do the work. Okay. It's a lot of work, but when you walk out of this class, you will actually know a lot of information that will help you in whatever major you choose. And I don't want you to be afraid of technology when you leave this class. You might be afraid of it right now, but when you leave, I've never encountered a student who's afraid of technology once they finish this class. Okay. So those skills are important. Analytical reasoning. Okay. Critical thinking, experimentation. We try things. You get to try the labs. Okay. If you want to try more than the 5 labs, you're welcome to it. And you can maybe get some extra credit. Infrastructure. Okay. These costs are going to continue to decline in the future. They're pretty much commodity. Very rarely can you go out now as a business and say, hey, I'm going to go out and sell computers, right? It's not a business any investor is going to give you money for because there's no money to be made. The margins are very slim now. Used to be, back in the day, I remember Dell and EMC used to take us to steak dinners and seafood dinners to try to get us to buy their equipment, okay? I don't think that happens so much anymore because the margins are so thin on the hardware. They're having to branch out into services and software in order to make money, okay? The other area here, artificial intelligence. This is going to continue to transform pretty much any industry, okay? So I'm hoping to get it to work. I've got this camera that works with a cloud provider called Amazon Web Services. If I stuck it on the desk here, after a few seconds, it would scan the room and it would be able to tell me that you have a baseball cap on. That's a baseball cap. Person, okay? That's a laptop. All in real time. As I move the camera, it would in real time be able to analyze you, okay? That's artificial intelligence. Cybersecurity is becoming so important, okay? It used to be that you could get by with patching your computers and you'd be okay. Now we've got phishing attacks happen all the time, okay? And I'm a computer guy and I've actually fallen victim to these before because I'm not paying attention. I'm on my phone and say a dean of a college emails me. I don't look at the content to see if it's actually the dean. I see the name and my mind is, oh my gosh, I need my cell phone number, right? Reality was, it wasn't the dean. If I looked at the email address, which is a little harder to do on your phone, I would have seen that it was not really the dean's email. It was dean whatever at gmail.com, not the school's email, right? So phishing is a very prevalent thing. Cybersecurity is going to become even more important, okay? It's very important here in California now because as of a little over a week ago, the California Consumer Privacy Act is now in place, okay? We have some protections from a data privacy perspective, okay? If there's a cybersecurity breach, there's certain things that companies have to do to help protect our data from breaches, okay? Data protection, moving on to the next one, CCPA here in California. GDPR is the European version. It actually surprisingly applies to businesses in the US and worldwide, even if you're not in the EU, okay? So as a business, you've got to be constantly thinking about what type of data protection do you need in your information systems. And then I already mentioned Internet of Things, but cloud, smart devices, 3D printing, augmented reality, virtual reality, which some of you will hopefully experience. Those are continuing to grow in popularity. Did you know that Walmart is using virtual reality for training now? Anybody work for Walmart? If you want to go work at Walmart in the deli, apparently you have to take training on an Oculus device. Okay, so you don't burn yourself on the chicken fryer. Okay, United Rentals has implemented Oculus VR for training people on heavy equipment operations. Before we go give you the big crane to operate, where you go and smash someone's car, we're going to make you do it in virtual reality. And once you pass that test, then you can actually go do it, okay? This is becoming common from a training perspective, right? Now, there's one other form that's not listed here it's kind of in between AR and VR. It's called mixed reality. This is like the Microsoft HoloLens. This is actually becoming really prevalent in business when you have remote offices. And let's just say you own a factory in Europe and your main technician is here in the US. You can do what a company I work for had to do and fly your technician overseas. We had a guy, he accidentally did something wrong. He shut down our Singapore data center remotely. Now, once it's down, you can't get it back up aside from flying someone on a plane. If we had that technology a dozen years ago, we would have been able to pop one on in the US, technician on site in Singapore could pop one on, and the person in the US could see exactly what the person's looking at and work with them in real time with their hands and show a point at this button, and the person could see on their HoloLens, he's pointing at this button. I need to push this button. Not just telling them, but actually pointing and doing it. That type of interaction is now possible with the HoloLens and other similar technologies, okay? So it's not just for gaming anymore. All right, so now let me go ahead and switch to the computer section, okay? And these slides, by the way, are posted. All right, so the second unit is on computers and computing, okay? So you should understand the basic history of computing technologies. We've had a lot of change over the last 60, 70 years in computing, okay? We started off with only the government being able to afford to have these massive custom-built computers to the point where we can just go out and go to the store and buy a computer if we want, and we can buy a little computer, a Raspberry Pi or something for like $10, okay? That's how cheap they've become and how miniaturized. You should be able to understand the components that are inside computers. At some level, you should be able to understand the power of computers, okay? The different types, how computers process information, define what software is, and the different types of software, because there are many different types. And I'll cover some basic categories, but it would be impossible for me. I'd have to have a whole class on different software because there's just so much of it, okay? So starting off in the 40s and 50s, we had the first generation. These are machines that take up an entire room. So imagine one computer taking up this entire room, and now you know what computing was like in the 40s and 50s, okay? And those machines had less power than like one of the little calculators that none of us use anymore, okay? The little simple calculators have more power than one of those did, okay? The second generation in the 50s and 60s was still bulky. This is where IBM really grew into this big global company that we all probably have heard of, okay? But it's still very bulky. We haven't been able to miniaturize the components enough to make it less bulky. So that gets us to the third generation in the 60s and 70s. We're starting to shrink these devices. So now instead of a room, they might be 4 refrigerators in size, okay? This was because we developed things called integrated circuits, okay? We also had very early network connectivity. So now a machine in Delaware can communicate with a machine in New York City, okay? Not very quickly, but we can still communicate between the machines. IBM is still the market leader. The fourth generation is really where we start seeing things happen in the 70s, 80s, and 90s. This is the personal computer revolution, okay? This is when Apple was founded. This is when Microsoft was founded, okay? IBM's still out there, but now they're starting to subside and be replaced with clones. Now it's possible for someone to just go build a computer. So like Michael Dell is an example, okay? He goes out and he builds a computer, he brands it Dell, and now he starts selling computers called Dell. IBM sells computers. Compaq sells computers. HP sells computers, okay? I don't even remember all the manufacturers, but when I worked at Staples many years ago, there were tons and tons and tons of these companies that were making computers, okay? These are personal computers that would be like something along those lines, okay? And mini computers, which would be along the lines of maybe half of a refrigerator in size, okay? Then we get into the fifth generation, which is the 1990s to the mid-2010s. We end up with PCs, Mac, desktops, laptops. In the 90s, laptops were less common. I worked for a company that deployed laptops for the first time in 1998. Okay? Before that time, you didn't have a laptop unless you were an executive, okay, or worked on the road a lot. I remember my grandfather had a laptop. It was this thick, okay, back in the early 90s. He wouldn't let me touch it because it was for work, but Amico gave him this laptop, and it would last on a battery about 20 to 30 minutes. So it was just long enough for him to go and pull up some important document when he was out doing construction on these plants, okay? Then we have things like Windows and Mac OS are really becoming prevalent, okay, and more useful. We have things like internet, we have USB. USB was like this game-changing technology for the computer industry. Before USB, every type of device you had a different type of connector. Oh, you have got a printer? It has its own special connector. You want a keyboard? It has a connector, and it could be 3, 4 different types of connectors. So you'd have to buy a keyboard just for the connector you had on your computer, and they were all different, okay? You want to buy a computer for your Mac? Sorry, guys, you got to go to the store that only sells Mac keyboards and spend $50 for a keyboard that the PC people can buy for $5, okay? That sort of thing. USB changed that. Now we've got one type of standard and we still use it today. Okay? We still use that standard today. Bluetooth, that's when Bluetooth started originating. Now, instead of me having to have a wire chaining me to the desk over there for recording, I've got this headset that allows me to record and stream it over there. Speaking of which, I should probably check to make sure it's still recording since I don't have it on my ear. Okay? We'll check it and make it think it's on my head. Then we get into the mid-2010s to the present. This is the 6th generation. This is where NVIDIA, has anybody heard of NVIDIA before? Okay. NVIDIA makes graphic cards. What they also do is they make graphic computers, or GPUs, that actually allow AI to happen. Okay. It's only since 2010, so only in the last 10 years, that AI has really taken off. Okay. And that's, a lot of it has to do with the GPUs that are being used because someone discovered, hey, a GPU is great for an AI algorithm. Okay. We also have these internet devices, Internet of Things, so we're moving beyond just computers. Now we have devices like smartwatches, okay? We have phones, et cetera. We have sensors, that kind of thing. And then we have this new thing that's just now, we're just at the cutting edge of, just starting to take off, quantum computing. I don't know where that's going to lead. It's beyond the scope of this class, okay? But quantum computing is a new area where instead of dealing with electrical signals, we're dealing with atoms and using that for a computer. I wouldn't be qualified to teach you on quantum computing, okay? Very few people in the world are today. Now, computer components, and this is where I'm going to spend some time. I'm going to do a demonstration here in a minute. We have major components. There are a lot of components in a computer, but we'll talk about some of the major components. We have what's called the central processing unit, okay? And this is the brain of the computer. This is where all the instructions happen. It tells the computer to open your Word file, print your document, get on Facebook. Nobody uses that anymore, but whatever you might be doing, okay? The random access memory, or RAM, is the memory of the computer. It's so it doesn't forget things, okay? It's where it stores things temporarily. When the CPU needs it, it pulls it from RAM. And the reason for this is RAM is very fast, okay? A hard drive is not very fast. Even an SSD drive is not very fast compared to RAM. RAM is super fast. We're talking nanoseconds, okay? Faster than I can snap my fingers. But the problem with RAM is if you turn off the power, you lose what's in RAM. It doesn't save it unless there's electric power coming to the computer. So that's why if you've got a Word document open, you should have autosave on, because if not, it's not saving it until you click save to the disk. Okay? The motherboard, the way I describe the motherboard, I don't know why it's got that name, but it's basically this big board. It's about the size of the inside of this computer. I'll open this up here in just a second. It's about this big. It holds the RAM, the CPU. It has cables that connect it to the power. It has cables that connect it to drives and DVDs and your mouse and your keyboard. All of this is going through the motherboard. It's very important. Okay? And the reason why this one actually doesn't work right now is because there's a problem with the motherboard, which is why I feel like I could bring it in. It's not going to break anything. Okay? So then you have the disk drive, and this is where we store data long term. And there are different types of data disk drives. Okay? So a disk drive can be anywhere from a magnetic type, less common by the way these days, where it uses magnetic properties. Okay? Hard drives. If it's a spinny hard drive, it's a magnetic drive using placing data onto the hard drive with a magnet. Anybody here have a computer with a floppy drive still? Okay. I haven't had one for like 20 years with a floppy drive. But back when I was a kid, that's how we used our data. Okay, we had these floppy drives, and every paper for school was on a little 3.5-inch wide floppy. Okay. Optical drives hold a lot more data, but still not as much as a hard drive. Okay, a CD or DVD ROM are examples of optical. There are some other ones as well. And then we come to solid state. SSD is effectively kind of like RAM. It's computer chips that store information, but it's been developed in a way that it stores it even if the power is lost. Okay? So most of our computers today, especially if you've got like a MacBook Air, I guarantee you have an SSD drive. There is not room in a MacBook Air for a regular hard drive. Okay? It would not be physically possible to have a disk that small that spins around. You'd have a lot of issues. Okay? So when I don't want to disconnect my computer because I disconnect the live stream, but this thing you can see is very thin inside. Okay, not a lot of space for things. The components, each one of these components has been miniaturized. Okay? A lot of research and money has gone into miniaturizing the computer components. Whereas in this thing, they're big. Okay? This is a gaming computer, by the way. Not every computer is like this that's a desktop. The one in here that's in the classroom here is a little tiny desktop because it doesn't need as much resources. It's just for showing slides and things like that in class, okay? Now, then you have input devices. So we have things like the mouse and the keyboard, okay? We all know what those look like. But we also could have things like pens, a tablet to write on, okay? That sort of thing. Touch screens are a type of input device, okay? A touch screen, interestingly enough, is an input and an output device because you touch it, it's taking input, but it also has got a display in it behind the touch screen that's actually projecting the data. So it's an output device as well, okay? A camera is another type of input device. Inputs video or pictures into our computer. Okay? And then a scanner. Not as common, mostly in business do we see these, okay? These days, if we want to scan something, a lot of times we just use a camera app on our phone to scan it, and now we get a picture of it. But it used to be, before camera phones, you would have a scanner at home and you would scan in something that you got on paper, and now it's in your computer. Or you'd scan a photo in or something. We don't need to do that anymore because we have smartphones with cameras on them. An output device could be a printer, okay? It could be a monitor or a display. It could be a disk drive because we could be outputting data off our computer onto an external disk drive. It could be a USB stick as well. It could also be a speaker or a headphone if we're listening to something, okay? So that's another type of component. So with that, what I'm going to do is I'm going to go ahead and hopefully get this thing to work, okay, where I can show you some things about this computer. First of all, this is the case. This is not the CPU. This is a common misconception. People say, oh, this is the CPU. This is not the CPU. This is the case. Cases can be interesting looking like this one, or they can be plain like the one that's sitting in the cabinet here, which I can't show you, unfortunately. Okay. You can also have cases with blinky lights and motion lights. Gamers get really big on this. Anybody a gamer? Okay. You probably build a rig that has flashing lights and special cooling systems and stuff like that. For the next few minutes, because you've got something like this, you can probably take a nap, okay? Because you probably understand what I'm talking about here. Okay. All right. All right, so this enormous thing here, which we'll zoom out. This is called a heat sink, okay? And the way to describe this purpose of this thing is think about your house, okay? Or your car. You get in it, it's a hot day. You could cool yourself with the fan or you could cool yourself with the air conditioner. Which one's more effective? Air conditioner, right? So the air conditioner is pumping a liquid or a gas through it, and then there's a fan blowing against the gas in the condenser array that's actually then cooling the air much more efficiently than a fan can do. This computer has what's called a heat sink and a fan. The purpose is CPUs and memory and the motherboard get very hot when it's got electricity on. I would not want to touch the inside of this thing when it's plugged in. Not only I might electrocute myself, but more likely I would burn myself, okay? CPU gets very hot. After I turn off the computer when I'm working on this thing, I have to make sure it's nice and cool before I do it. So it's usually an hour or so I'll wait before it because I don't want to burn myself. They get very hot. The more you use the computer, the more the memory and the CPU get used, the hotter they get, okay? So the purpose of a heat sink is to draw the heat away from it and dissipate it. And so this particular computer has a heat sink, this massive tower, which looks like a skyscraper, okay, on the motherboard here. Yeah, look, looks like the Matrix, yeah, okay. This is a heat sink that's like a radiator in the front of your car. It dissipates the heat away from the engine, okay, same thing. But what it has on the other side, which I don't think you'll be able to see very well, is this is a fan, okay. This is using fan-based cooling. So the heat's going up to the heat sink, the fan is pushing it out, this vent on the back of the computer here, okay. Now, if you have a gaming rig, more likely these days you have what's called liquid cooling, like the air conditioner example, okay? It has liquid that comes in cool, either it might be water, it might be some other type of liquid, but it comes in cool, it goes around the CPU on that heat sink, and it turns warm and pushes it back out where it gets cooled out outside with fans or something, okay? Depending on the type of computer, you either have liquid cooling or fan in it, okay? All of our laptops are using fan-based cooling or no cooling at all. They might just be using normal airflow, okay? Especially the very micro laptops. An iPad, a phone, they don't have fans in them. So the only way they can stay cool is being out in the open. So that's why if you leave your phone in your pocket and it's on and it's doing something extensive, like maybe you're running an app on it or something, it can get very hot in your pocket, okay? Because it's blocking the airflow. Similarly, if you're laying in bed playing on your laptop and you got a MacBook like I have, okay, there's the ventilation's kind of on the back, almost on the bottom. So if you've got it on a blanket or a pillow, it gets really hot and you'll hear that thing start going. It's because it's trying to cool it. But it's limited how much it can cool it because it's got a tiny little fan in it because it's so compressed. When this thing's turned on, you can hear it. It's loud. Okay? It's got a bunch of fans in it. Now, it has another component in here, and I can actually remove it. This is a video card. Okay? I don't know how that works. Move this out of the way. So we've got this video card, okay? And this video card has a connector on it, which connects to a monitor, that one in the middle. But they all would connect to a monitor. The one on the right is for a really old style monitor, the old big TV kind, okay? The one in the middle is HDMI like our TVs have today, and the one on the other end is a type called DVI that we don't really see anymore, okay? But this video card processes the signal from the computer and displays it as a graphic on the screen. Now, this computer has a built-in video card on the motherboard. It's not very good, okay? You wouldn't be able to play games on the one that's on here, but you could probably surf the web and use Word and things like that. So you have a video card as a component that can be used to display better graphics, allows you to do games and things like that, okay? And they have this connector on the bottom, okay? It plugs into the motherboard. There's a special slot that plugs into, okay? So that's one such component. Now, not all these components are actually going to be able to come out of here. But another thing is the memory. So I can show you the memory. And this memory is very fancy. They wanted to protect it, okay? But you can see, again, there's a slot that it fits into, and there's pins on it, those little coppery looking things, okay, gold things. Inside, behind this plastic case, there are little chips on here, like little tiny miniature chips. Most RAM that you see doesn't have this nice little pretty case on it to protect it. Most of it's exposed, so you have to be very careful. So most of the time with RAM, you pick it up like this, so you don't actually get your fingerprints on it and potentially damage it with the oil from your skin, okay? So this is a stick of RAM. And generally in a computer, you're going to have multiple sticks of RAM. So this computer happens to have 2 sticks of RAM. It has places for 2 and there are 2, okay? Now, so that's the RAM. All right, so another thing that they have, I am not going to be able to get it out of there, is a hard drive, okay? So the hard drive is this device. I got it out. Okay. It's this device here, and it's got some computer chips. You can see the backside here. There's a little computer chip in here. And you can see this thing in here. You can't see inside it, though. This is a magnetic disc that spins around. Okay? My nephew doesn't have a lot of money, so he couldn't afford an SSD drive. He got basically a drive with a spinning magnetic disc in it, okay? The data gets stored on this hard drive, okay? It's connected with a cable, and today, the cables are standardized. But back in the day, there were many different types of hard drive connectors. So you could buy a hard drive at the store, get it home, go to plug it in your computer, and it wasn't compatible, okay? Today, much easier to build a computer because there are very few types that you can go buy at the store now. So he built this at Fry's, by the way. So you can actually build your own computer just by going to Fry's. They've got a whole section to build your own computer, and usually it's cheaper than buying one at the store because you get to pick the components and it looks exactly like how you want it. Now these cables in here, they're inside a protective cable, but these are power cables. Everything in the computer has to be connected to power. So if you look at, I don't know if you can see, but there's this, let's see if I can get it forward. This is a power supply. On the back, we plug it into the wall, okay? On the back, it's got a plug, okay? There, you can see the plug up there at the top. That's how we plug it into the wall. This converts power into individual streams of power, just like in our house, we have a power line that comes in, and then we have outlets throughout our house that we plug into, or our apartment or whatever, okay? Same thing with the computer inside. Each one of these cables provides power to something. So there's a cable that plugs into the hard drive. There's a cable that plugs into maybe a CD-ROM drive. Then there are a bunch of cables that plug into the motherboard, okay? And the motherboard has different types of power because different components need different types of power, okay? It's not an engineering class. I'm not an engineer, so I'm not going to explain it. But if you're interested in that aspect, there's electrical engineering classes you can take on power. There's different voltages that are required, and that's what the motherboard has in it for, okay? So then inside, underneath this CPU heatsink, unfortunately, I can't pull it off easily. Maybe I can. There's a CPU inside. This computer will not look like the way it was when he gave it to me. Okay? He trusted me to fix it for him. I don't know if I'm doing that or not. I might, yeah, that might be next, yeah. So this thing has a CPU in it too. And almost there. Okay. So the heatsink comes off, and that's the CPU right there. That little thing, it's upside down, and it's actually glued to the heatsink. Okay. So this is actually a CPU for his computer. All right. Now, that actually also allows us to see the motherboard a little bit more. This is the motherboard. A lot of junk on it, right? Okay. So we've got the memory in here. We've got the CPU goes here. We've got lots of different chips, and then we've got on the back all the ports that we connect to our computer for the mouse and keyboard and stuff like that. Okay? So that's the inside of a computer. Now your laptop is just a miniaturized version of this. Okay. All right. Any questions before I go on? All right. So power of computers. Now, if you're fortunate enough to be a Mac user, chances are you don't even think about the power of the computer anymore because Apple doesn't market it. Unlike a lot of other manufacturers, Apple doesn't say we have a new computer with a 10 gigahertz processor. Okay, they just don't do that anymore. What they do instead is they say we've got a MacBook Air and it's great for doing video, or it's great for being on the go. That's really all they do for their computers. They don't really label them with any particular specifications of what they should look like. Okay? But if you go to Fry's or Best Buy and you're looking at a PC, you'll see a little card in front of it that says it has 8 gigabytes of RAM, okay? Or 50 terabytes of disk in it. Okay? What we really consider for most people well, there are 3 factors. One is accuracy, one is storage capacity, one is speed, okay? But us as lay people, we care about storage capacity really, speed. We don't really think about the accuracy because for us, as long as the computer can do what we need it to do, we don't really measure that accuracy. Now NASA, on the other hand, has to care about that sort of thing. So a computer NASA builds or buys, they care about the accuracy because it could mean the difference between landing on the moon and crashing on the sun, okay? That could be the difference with a computer that they use. For us, we don't care about that because our computers are accurate enough for the work that we perform, okay? So what we really look at is storage capacity. So for RAM, it's usually in gigabytes today. It used to be in megabytes, and a long time ago, it used to be in kilobytes, okay? But now they're in gigabytes. I don't know if in my lifetime we'll get to terabytes of memory on a personal computer, if it'll ever be needed. I don't know, okay? But hard disks have moved throughout my career. They started off when I was in school as megabytes. 20 megabyte hard drive in a Mac was not uncommon. You couldn't even store an entire class's worth of Word files these days because they're so large. Moved to gigabytes. Terabytes we're starting to see in our personal computers now. You know, we have a 3 terabyte drive or something. But businesses tend to have data that's in the order of petabytes, exabytes, and beyond, okay? Petabytes, exabytes, zettabytes, if I'm not mistaken. Okay. Speed, on the other hand, can be measured in different ways. So network and memory speed are usually measured with the number of instructions per fraction of a second. Okay, that's where I mentioned nanoseconds earlier, milliseconds, nanoseconds, microseconds. Usually we measure things in milliseconds and nanoseconds in the computing field. We don't generally measure in the other ones, but they're there for reference, okay? So for example, if you're on the internet and your internet's slow, you can use a command outside the scope of this course, but there's a command you can use that you can test your network connection. It reports back in milliseconds. It took 20 milliseconds to get to Amazon.com. That's pretty darn good. It took 800 milliseconds to get to Amazon.com. That's bad, okay? So that's measured in milliseconds. Speed of memory is measured in nanoseconds, which is even smaller than a millisecond, okay? So that's how memory speed, again, if you're buying a computer at the store, you aren't gonna ever see these values. The only speed you're ever gonna see in a store is the CPU speed, okay? And the CPU speed these days is in gigahertz, okay? It's a 3 gigahertz processor. It's a 4 gigahertz processor. Now, it's possible that a 4 gigahertz processor is actually not as good as a 3 gigahertz processor because it's a different type of processor. This is the problem with those types of comparisons, okay? So you don't just rely on those metrics that you see in the store because they may not be entirely accurate, okay? Your best bet is ask yourself, what do I need this computer for before you ever go in and buy one? And if your answer is, I just want to write my papers for college on it, then your best bet is to go just find a simple computer because any computer will do it for you, okay? Go find the cheapest one possible. These really matter if you're into gaming, and as a business, these matter for your servers, okay? They don't really matter for the desktops you buy for your employees. Who cares anymore? Computers for employees all work the same, and unless you've got an employee who's like doing video processing or really high-end graphics, it doesn't matter anymore, okay? Now, input devices. So I've mentioned a number of these already. A barcode reader is used in stores, okay? You scan at the cash register, it's got a little scanner that reads barcodes, okay, as input. RFID reader, this is used in warehouses. An NFC reader, this is used for things like Apple Pay, okay? That's a near field communication device. Then you have things like optical character recognition. This is really cool. How many of you are finance or accounting? Okay, there is a technology that I did briefly mention before that is going to completely transform the way you do your business in that field. It's called robotic process automation. And one of the things it's capable of is OCR. Okay, imagine your company gets 1,000 invoices in the mail every day. Someone has to manually enter that data in, right? Not with RPA. You have one person grab them, take them out of the envelope, remove the staples, shove them in a scanner. As they come in, they just get shoved into the scanner scans them, the computer reads it in, puts all the data into the database, then someone goes and pulls them out of the output tray, puts them in a paper file somewhere, never to probably be looked at again. In the meantime, no one had to do that data entry. The computer did it automatically. It's trained to be able to recognize it thanks to OCR, okay? Optical mark recognition, all of you use, probably very frequently, but the good news is you won't be using it in my class. No classes I teach do I use OMR anymore, okay? That's Scantrons, okay? That's one way of doing data entry. Another thing is the leap motion. I have one of these. It's kind of buggy, maybe it's improved. I've used it in the past before. What I like to do is I set it on the desk here, and I start moving things on my computer just by moving my arms and hands, and everybody thinks that I'm magical and have some secret power, okay? The reality is it's just measuring my hand movements, okay? That's the next technology I think we're gonna start seeing on our computers is the ability to manipulate things on our computer just by making hand gestures, okay? Biometric. This is really important in business because a lot of times you're dealing with sensitive data. How do you lock down that data and ensure that only John, who should be accessing it, can access it? Well, biometrics is one way. We use a fingerprint, we use facial recognition, we use retina scans, etc. When you go into those big data centers, by the way, they use biometrics to verify you. And the story I like to tell about that is I did a tour of this data center on the East Coast for a customer, okay? They brought in some high power people politically. And I like to talk about this because I walked in and I said, steal my card from me. Go ahead and steal my card. I'll even give you my PIN to get into this data center, okay? So they've got my PIN code to enter into the card reader. They've got my card. It beeps and it says, please hold for retina scan, okay? Unless they have my eyes, they can't get in. In addition to that, it also had a hand scanner. So even if they take my eyeballs out, they still can't get in because then they need my hand as well, okay? So there's all these multiple factors. This can really be used to take input and secure a system, okay? Output, we talked about video cards and monitors. There's different types of connectors. We have different types of printers. Laser printers, most common these days in your dorm or apartment, probably an inkjet printer. 3D printers starting to become more common, okay? You can get 3D printers for low-end ones for a couple $100 that can let you prototype things at home, okay? And then plotters are used for the big types of drawings like architecture and things like that. Output is audio and disk drives, so we have those as well. And then I mentioned laptops, desktops, servers. Some companies still use mainframes, but they're not as common anymore, mostly for enterprise applications at like airlines and big companies like that. Supercomputers, this campus used to have a big supercomputer facility. They had this thing called a Beowulf cluster. I don't know if it still exists or not, but supercomputers are used a lot in universities for research, okay? And then we all have our portable devices as well. Now, software runs on the computer. So if I ask you for software, it's not a tangible object that you can show me, okay? It's just effectively random ones and zeros, okay, which is a binary language that the computer understands. I couldn't go and say, oh, give me the software, and you couldn't physically show me the software because there's no physical object. There's a representation on your screen when you open the software, but at the end, the software is just random computer code, and at its core, it's just random ones and zeros, okay? Computer only knows ones and zeros, okay? Now, quantum computer will be different than that, but a regular computer uses binary. There are different classifications of that software that runs on the computer hardware, okay? So this is not my Windows, okay? It runs Windows, but it's not my Windows. This is a computer that runs Windows on it, okay? The software really enables the hardware to be useful because right now, as you can see, there's no software on it. That thing's not going anywhere. It's not doing anything. It's absolutely useless, okay? We have different types of software. We have system software, Windows, Mac OS, iOS, Android. That's system software. That's the basic software that allows it to do something useful, okay? We also have application software. So we're all familiar with our mobile phones have apps on them. That's a type of application software, okay? But computers have the same thing, different types of application software. Then there are the applications we access through the internet. That's a type of application software as well. It just doesn't run on our computer. Where does it run? A server, okay? Speaking of which, we get the attendance. Okay, make sure it gets up to the rest of the class, please. System software. So I talked about operating systems, but we also have things called firmware. Okay, firmware is like that video card I pulled out. It has a special type of software that enables it to work. If there's a problem with the hardware, they fix it with software. It's very hard to fix hardware with hardware after you've already sold it to someone. Usually means you say, return it to me and I'll give you a different piece of hardware, okay? It's very difficult to fix hardware with hardware. Okay, that's usually an upgrade. So firmware allows us to upgrade our hardware as new features, or if there's a bug, and a bug is just an error in the software. So let's just say we have a Mac, and let's not use a Mac for example. Let's use a phone. Okay, every once in a while you might get a prompt for carrier update on your phone. Does anybody get that? There's a carrier update. That's a firmware update for the software that's used on the cellular device inside your phone. Okay. Without that, there could be problems with your cellular carrier. So it's very important. We have firmware on things like maybe a mouse, a keyboard if it's an electronic one, might have firmware. A printer might have firmware you might have to load periodically because there's some sort of problem with your printer, okay? Application software can have different types. We have desktop, so things like Microsoft Word, Office, Photoshop, okay? That's a desktop software. We run it on our computer. We also could run that sort of software on a mobile device. Okay? The idea is the same. Then we have cloud-based software. Has anybody used Salesforce? Okay, one person. Okay, Salesforce is a cloud-based sales management software. Okay, a lot of companies use it. I don't teach it in the class, but there are a lot of free classes you can take through Salesforce's website, and it's a great way to differentiate yourself on your resume. Okay, if you know some of it. Google Docs is one that we all use. The campus subscribes to Google Cloud, the Google Docs cloud, okay? And that allows you to do documents with your peers, do email, etc. And that's all part of a cloud-based software. The last one is the one I mentioned, server, okay? This is not something you and I are gonna install. Is anybody an MIS major, IS major, IT major in here? Okay, a couple people. You will, in your careers, you will have to learn how to do this, okay? So that's something like a web server. A web server just serves up a web page. That web page that you go to for the course, that is a web server. Okay. You go out and you look at a page, but at the back side, I know this because I spent the weekend fixing it. There's a database that stores all the information about the page and all the links on it. There's an application running called WordPress. And then there's a web server that runs WordPress so you can actually access it. Okay? All those components combine together to make an application called My Course Website. Okay? Without all three of those components, it wouldn't work. Okay? If I just had a web server, then I would be manually going in every day and writing HTML code, which is not fun. I used to do it a long time ago. It takes a long time. Every time I need to make a change, guess what? I'm going to probably spend 2 hours updating the web page just to add one slide deck to it. Okay? So then the database server is where all the data is stored. Okay. All right. We made it through, and I did that demo already. So let me show you real quick cloud application software. Okay. And then, and then we will have time for any questions. So I'm going to show you the class website on the back end. Okay. It'll take just a second to open up. I'm got to enter my password. Okay, any questions while I'm waiting for it to load? Yes. Oh, yes, the minutes that are due on Tuesday, okay. If you have not formed a group yet, you need to do it by the end of your discussion tomorrow, okay? And then you need to meet. The minutes, what you're going to do in them is you're going to bring them to the front, but what you're going to use a template. You're going to have everybody's name in your group, okay? Whether they're there or not at the meeting, their name. Next to it, either absent or present. Everybody who's present will sign the minutes. You will assign any action items, okay? Your first deliverables for this are not due for a while. So really what you should be doing this first meeting is introducing yourself to each other, figuring out when you're going to meet, how often you're going to meet. You're going to probably meet very little in the beginning, once a week probably, maybe for 15 minutes in the beginning. As you progress, you're going to need to spend more time together, okay? Whether it's virtually or in person, okay? You're going to document all your decisions in the meeting minutes. Okay? You don't want to leave it up to interpretation. That's where you get yourself in trouble, is if you think that you all agree on something, if you don't put it in the meeting minutes and there's a dispute later on, how do you prove who was right, okay? Yes. Well, you can do them, so you can do a meeting virtually, do them virtually, but then you all need to sign them when you come to class before you turn them in. But the reason is there's an academic certification at the bottom, and that's to make sure that you're all participating, okay? There's a template, yes. It's got like, I think like 6 names. If you need more, you just copy and paste the template to add the more names to it, yeah. I would say that you probably need 15 to 20 minutes for the first meeting because you're just introducing yourself, setting schedules, deciding what you're going to do. And the other thing is you need to start looking at the problem that you need to solve and figuring out how you're going to divide up the work later on. You don't have to start doing that all right now. You can. It's designed to be a course length project. So it's designed for you to actually start doing it and actually utilizing it on an ongoing basis throughout the course, because it'd be better to do it piece by piece throughout the course than waiting to the end. So you're going to have a lot of stuff to do at the end, okay? But that's not to say that if you need some more time to figure it out, the first meeting is really just for you to introduce yourselves and get your schedule figured out, okay? Which is why I wanted you to work with people who have similar schedules, okay? If you do it with your discussion section people, then you have the added flexibility. If you're done with discussion section, you have that ability to meet before and after the discussion section if you want, okay? So there is an advantage to doing that, but based on the student requests, I open it up. We can be partners with anybody in the room here if you want, okay? And so this is what Amazon's server looks like for where this WordPress is. This is the website that you see. On my side, I have computers, okay? And my computers are out here and I can virtually touch them, okay? They're software. They're running on a hardware somewhere, and I don't know, the Bay Area, I think, okay? And I've got 2 servers here. And I can connect to them, even though I'm not physically located near them. I can pick one, and I can connect to it. Okay, these are the web servers. My database is a little bit different, but I have a database server as well. I can connect to them, and then I can actually connect to them through the web, okay? And remember I said command line earlier? Oh, you know what? I've turned off the access because for security, I wouldn't want people to be able to get into my server. So you can't actually get to my server right now. But if I did, it would pop up a command line, and then I would have to interact with it with a keyboard, okay? I would have to know the commands to do things, okay? I don't have a GUI that I can go in and click around into my WordPress server, okay? So whatever I do in the back end is what displays here, okay, for this class. All right, so any other questions? All right, so the labs, and then I will let you go, okay? And if you have questions, you can come up here. The labs. If you're thinking about doing an advanced lab, that's okay, even if you're not an MIS major. But please don't spend a ton of time on those advanced labs. If you get stuck, seek help, okay? Yes. We'll do it outside at the back of the class. Where's the attendance at? Okay. What's that? You didn't get it again? Where's the attendance? Okay. Let's just take it out back and do it on your way out. Just take it to the back there.